Okay, for the white homework packet, I have been able to make a lot of different videos in different classes. So there's already, I believe, 10 videos posted of the 16 problems. Today I'll try to make a few more so you have lots of help if you need it. You can, of course, come talk to me as well. Okay, number 5 is a really good example of if you won't, you should never, on an AP question, you never want to like pick at the problem. What I mean by that is you never want to just find a number here, find something here, and somehow think you're supposed to do this. Like you want to get a clear idea of what they're talking about. Once you understand the big picture, the little steps become really easy. As I read this problem, it says, the number of gallons P of a pollutant in a lake. So I stop and think for a moment. So P represents how much pollution is in a lake. So just say it out loud, please. Is P an amount or a rate? Amount, okay. So P is an amount. But then they give me a formula for the rate. They give me P prime, so the rate at which P will change. They give me a bunch of units. It says there are 50 gallons of pollution in the lake at time equals 0. As soon as I read that, I'm going to write on my paper P of 0 equals 50. Nice. Okay. The lake is considered safe when there are 40 gallons or less. So I would probably just box that. Okay, it's an FRQ, so this is always information. There's never a question here, just information. An investigator uses the tangent line approximation to P. I stopped reading. You need to learn when you're doing the AP test to stop reading often. Okay, investigator uses the tangent line approximation to P. That reminds me of my favorite picture. I have a graph of P, so I'm going to cheat a little bit. I happen to know that it will make more sense if we draw P this direction than the other direction, because the pollution level is dropping. So I draw P, and now I'm supposed to have a line that is tangent to P. So I draw that. Not very well done, but there we go. Nice. Good enough. Okay, so there's my line that is tangent to P. It says an investigator uses this line. So they're going to use the green line, not the pink curve, as a model for the amount of pollutant. So the idea is they don't have any way of calculating the pink line. So instead they say, we'll just use the green. We know they're not the same. As long as we stay pretty close to this spot, like look here. In this region, the green and the pink are pretty much the same. So if we just don't go too far away, it's a decent approximation. Okay, that's the big idea. And they do like to test you on this regularly every year. So any part of this big idea that's bothering you, now is a good time to just talk more about it.
So are they trying to clue you in that they're using derived PFT?
Good question. 2 points, but no. So this is P. It's a formula for P prime, but this green line isn't P prime. This green line is its own equation. Because it's a line, it has an equation that looks like this. We're dealing with time now, so instead of x, we'll use t. So there's 3 equations in this problem that are important. There's the equation for P, there's an equation for P prime, and then there's an equation for this line. Yeah, so the line isn't P prime, it's its own equation. And what they're saying is, let's find an equation for this, and we'll just use that as our approximation for the pink.
So we put it into point slope form.
For our class, point slope form always works best. Yeah, good question. 2 points. Okay? So it says an investigator uses this equation as a model for the amount of pollutant. It's as if they're saying this. They're saying, well, I don't know the equation for P, so I'm just going to say this. P of T is approximately this equation. That's what they're saying. Other questions, please.
So does it only predict it on that line or at any tangent slope?
So we're going to use this exact line to pretend that it's the pink.
Okay.
You could have had another one, like I think this is what you're asking. Could I have drawn a tangent, say here, and use that to approximate the pink? Is that what you're saying?
Yeah, I just didn't know if you were like.
Gotcha. No, we could have used the brown, but we're not because they specifically said use the line that is tangent at time equal 0.
Okay.
So I'm going to label that. So this is time equals 0. And we already figured out that when time is 0, the value of P is 50. So that's what we have. 2 points. Again, your focus at this moment needs to be big picture, not little steps. Like understanding that you have 3 different equations here. There's some equation for the pink. We don't know that equation. But if we had the equation for P, we could find any point on the pink. If we had an equation for the green, we could find any point on the green. We have an equation for P prime, so we can find any slope on the pink. This equation up here for P prime is how we find any slope on the pink. But three separate equations. Question, please. This one here. The mix-up is between what is meant by the equation of a line tangent versus the slope of the line tangent. So this is definitely, like P prime represents the slope of a line tangent to P at any point. So I can use this to find the slope of P here, or the slope of P here, or the slope of P here. This equation is different. This is how I would find any point on the green. Did you hear the difference? Perfect. So I'm going to say it back to you one more time because that is it's a crucial difference. Don't mix up what we mean by slope of the line tangent or equation of the line tangent. Totally different. This isn't an equation of a line tangent. This is an equation for finding the slope of any tangent line. So this will find the slope one more time here, or here, or here on the pink. That's what this does. This finds points on the green. Please. 2 points.
Did we do something similar to this where we would derive a function or something and then have to find the point slope? I'm just getting frustrated because I like kind of remember doing it, but I don't remember how.
No, you're okay. In Unit 3, we did this exact same thing.
Okay.
Yes, we are going kind of back again.
Okay.
Yeah, Unit 3, I believe on the test itself there would have been a question that was worded almost exactly like this.
Yeah.
And it was a case where you'd have some function f, and you would take the derivative of f. So now you have f prime, which is how you can find any slope on f. And then you'd need to find this equation for all the points.
And would you draw like a graph to find the zeros from the derived function? Like you had to find, I feel like we did something with the derived.
There may have been a problem that used zeros, but that would have been unique, not like general. So the general idea is you have an equation for P. This problem's a little different in that they already gave you P prime. So they didn't give you P. Like what you're remembering is where they actually gave you P. You find the derivative, you find P prime. Here they kind of course, they just shuffle the deck, right? So now you have P prime. You don't know what P is, but that's okay because they're not asking for P. They're asking for this equation. Good questions. 2 more. please.
So, wait, I'm confused on when you just said they're asking for that equation, right? So exactly, I'm so confused on
Okay,
that.
keep talking. So, all eyes up here, everybody. Just like really good questions. You're digging exactly in the right area. The key thing is to understand that we are talking about 3 separate equations. And each equation has a specific purpose. So I want everyone to raise their hand on this one. I do not know the formula for P. But if I did, what would be the primary purpose of that formula? Like what would its main function be? Hands, come on. If I have an equation for P, what is its main use? Elijah.
Find at any point on P.
Perfect. And P is which color? Pink. So if I have an equation for P, I can use that equation to find any pair of coordinates on the P. In this case, it's time and pollution level. So I can go to any time, I can find the pollution level at that time. Show me your hands if you knew that. Okay. Point 2 for Elijah. Hands up. What is the main purpose for the P prime equation? What is the main purpose of the P prime equation? JJ?
Find the tangent slope at any point on the P line.
Perfect. This I can use to find at any time what the tangent slope or rate of change of P is anywhere on the pink curve. How many knew it? 1, 2 for JJ. We don't have an equation for this yet, but when we do, what will be the purpose of this equation? Your hands again. What's the purpose of this equation? Keegan?
Find any point on the green line.
It finds any point on the green. How many knew that?
So that's not
What?
actually the equation for the green line, you're just taking that to represent what it looks like.
See, I want to say it real quick.
That's not actually the equation for the green line, that's just what it'll look like.
Yes, perfect. Because I know that all of these points line up linearly, I have memorized that the equation will have this form. When the curve is who knows what, I can't do that. But because it's linear, I can. It's important.
So, because we're trying to find a point, so I'm using that equation.
Say it one more time.
Because we're trying to find a point, we'll use that equation instead of the prime equation.
Perfect. Because the P prime equation would give me a slope somewhere on the green, but it won't give me a point on the green. We need the equation for the green. Important.
So, since the green line is tangent slope, I can use P prime to find the equation for that.
Correct. Because, back to Ava's comment, 2 points here from Marissa, M represents the slope of the green line. The green line is a line, so it has the same slope everywhere. So I just go right to this spot, and I say I need the slope of the pink right there. I need this slope right here. But that's what this is for. So I'm going to write that down. I'll say P prime at time equals 0 is going to equal 1 minus 3 e raised to the negative 0.2 times the square root of 0, which is 0. And then what's e to the 0? 1. So then you have 1 minus 3, or negative 2.
Well, that makes perfect sense because by finding that, that's what you plug into the end in the point slope form.
Perfect. That goes here.
Okay.
Because this is the slope of the pink, right at that spot, which is the same place the line is tangent, so those slopes are the same. So now I know this goes here.
So use that equation to find the slope at that one spot, can we use that to find it at any spot?
Any spot.
That's separate.
Exactly. So I can put in any value of time, and I can find the slope anywhere on the pink. I just need the slope here. 2 more. Outstanding questions today. Questions? Everybody feeling okay about the big picture? So I can write this equation now because I know everything. The y and the t don't ever change. They're just part of the equation. M is the slope of the line. This is that value. It's a point on the line. This is the point that goes with it.
Wait, why are we like finding all this when we just want to find like what it's saying, like when it's 40 counts?
Give me a couple more steps that'll make better sense. 2 points though.
Why can't we like take the antiderivative of G prime and then solve it that way?
So what Colton is saying is, well, why not take the antiderivative of this? That would give us an equation for P. The logic there is perfect, except that we're just answering what they asked us to do. Like they specifically said, the investigator will use the tangent line approximation.
So that's what this process is.
And there's another reason why we are doing that. They have given you a formula for P, and with the techniques that you've learned in this class, there is no way to find the antiderivative. So it's actually a dead end. So there is no option. That's actually a real life example of why you might want to do this anyway. Because as an engineer, you'd say, I can't find that. But if this line is a good approximation, maybe it's good enough. In any real life, I think you'll understand this. In any real life problem, you are never ever trying to get something to be perfect because you can't. The best you can do is make it close to a certain tolerance, and as long as it's close enough for the situation, then you're good enough. So, questions? Okay, cool. So over here, I write the equation of the green. I guess I should have used green, but this will work. T minus 0 plus 50. I don't usually want to do anything more, but this is too easy to leave, so we'll go ahead and do it. Okay, so just reviewing now. Please raise your hand if you can tell me what the purpose of the red is. What's the purpose of the red formula? What can the red formula be used for? If you're not sure, talk to someone whose hand is raised. What's the purpose of the red formula? Let's go, McKay.
Find any point on the green line.
Perfect. So this formula can find any point on the green line. How many knew it? 2 points, 3 from McKay. Okay, question. Look at me. I've said this many times. Like I have a really good memory of what kind of questions have been asked on the AP test. The things you guys are asking this morning are like way up the priority list as far as importance. Like if you can understand this big picture, like, you know, the formula for P is how you find the points on the pink. Formula for this is how we find the points on the green. This is how we find slopes on the pink. That seems simple, but if you are really solid on that idea, it's going to open the door to a whole bunch of questions on the AP test. It's like they ask this kind of stuff over and over again. They just do it in a lot of different ways. But if you're comfortable with the big picture, they won't be able to fool you. If they won't be able to trick you by the wording or the way the problem is presented. So this is really good. Please.
So now all you need to do is equal that, set that equation to 40, so you know that at time 5, the lake becomes safe to use at approximately time 5.
Perfect. Perfect. If I put a graph on, I think it's easier for me to see. So I put a grid like this. This is time 0, so the axis would go here. And the pollution level is measured on the y-axis. So right here, the pollution level is 50. It says so. It's what Meredith said. We want the pollution level to drop. I know my scale's not right, so ignore that. We want the pollution level to be 40. And ideally, we would have wanted to do what Colton said. We want to find this time here when the actual pollution level is 40. But we can't because we can't find an equation for P. Plus, they didn't tell us to. So instead, we do what Meredith just said. We go see when the green line has a value of 40, and we find that time. So we use this formula. And we say we want the y-coordinate to be 40. And then just with algebra, we can figure out that the value of t that makes that happen is t equal 5. That's exactly what they were expecting you to figure out. Always put units on my answer here. Days. So according to this, the lake is safe after 5 days. Question? Please.
That's just an approximation, right?
Yes, because we didn't use the real model for the pollution. And then it goes back to what I was saying to Colton. For our class, you don't have to worry about it. In a real life situation, you'd have to do some sort of analysis to figure out, is my approximation good enough? That sort of thing. So, questions? Awesome, well done. Okay, key things to take away from this problem. In the homework, and more importantly in the AP test, they will always have a few questions that talk about a tangent line approximation. And they'll ask the question in different ways, but if you can just get this big picture clear in your mind, you really will be just fine. You won't be tripped. Question. Perfect. Next thing. Stop that one.